Okay, within these multiple definitions I've talked about, I wanted to go through a bit of a typology of what those types of sustainable development definitions are. In a little bit more detail. So first of all, there's a set of definitions that are about a stock and a flow. So this is where sustainable development is a condition in which future generations have an equivalent stock of capitals. So they have an equivalent level of productive capacity. And so each successive generation is just living off the income from that. So I'll go through what stock and flow definitions look like and what the criteria is. Those definitions of sustainability have been around since the 1920s. So it's about 100 years in some natural resource fields. But more recently, we've started to, under those definitions, start to look at different types of capital other than natural capital. Another definition focusing on equity, focusing on intergenerational equity, is where future generations have equal rights to self-determination, which often means practically equal amounts of all stocks. So that is just it's the same principle, but it's in a different field, different way of measuring equity. And the human rights side of that is harder to measure. It's always harder to measure freedom and justice. And so we often use more economic concepts instead, such as the amount of a stock. Because if you have the amount of a stock, you could be making the same kinds of autonomous decisions about it as prior generations. Anyway, I'm making this distinction between equity as an amount of stuff and freedom or autonomy as the ability to make decisions. So that's from political theory, moral theory. So then the third one I'm going to talk about is carrying capacity, which is very much like a stock and flow type of definition, but it's typically in a more ecological field. So sustainable development under carrying capacity definition is a condition in which human society lives within the ecological carrying capacity of the earth. Oh, let me back up a second. So the distinction between those two is in that first, in the stock and flow, a capital stock, you're focusing on productive capacity. So that's quite an anthropogenic, economistic definition, whereas in carrying capacity, you're looking at the ecological productivity as a, for nutrient flows, water flows. You're looking at more ecological aspects with less regard for how they are productive of wealth. So capitals. And I'm going to just define capital as a factor of production, something that is not used up in the production of a good. So back to Adam Smith. Adam Smith's concept of capital was that Adam Smith was that capital, I'm just looking at what I've written there and realizing it's not exactly right. For Adam Smith, capital was actually the machinery of production. So there was capital and land and labor and organization. And for Marx, around the same time, there was a constant capital of the same machinery idea. This is again, industrial revolution thinking about capital. And then there was variable capital, which is actually money. In both those, early industrial economy kinds of definitions, capital was a productive capacity in making goods, whether it was machines or machines and money. Newer ideas of capitals include concepts of land and the sort of stock of a natural resource. So we have natural capital and physical capital. Physical capital, for example, could be land. Now we're changing land from, where Adam Smith has it as a separate category, we're changing it into something that has its own productive capacity. And we also have human capital, skills, knowledge, relationships, and organization. Now, for those of you in the community development program, you will already be familiar with the capitals framework developed by Cornelia Flora and partners. And I've put in a supplementary reading in case you would like to just refresh on that. For this class, we'll be using capital as any kind of productive capacity, including an ecological productive capacity, as well as any other kinds of productive capacity, at least metaphorically, including human capital, social capital, natural capital, physical capital we would call probably buildings at this point, and capital is money, enough money to start something up. So when I was talking about this idea of sustainability and sustainability in the capital stock and the productive capacity. So this goes back to the 1920s of the development of forestry and fishing in natural resource economics. And so that concept is known as sustainable yield. So if you think about a fish stock, in some population of fish in the ocean, biologists have thought that they could identify a number of fish that you could remove from the whole stock of fish. You could remove that amount every year and there would still be the same number of fish next year. Now, you can see on this little graph that idea is that you want to have not the same amount of fish next year, but these so that you can take the same amount of fish next year. So you can see that on the bottom part of that graph, there's something called fishing effort. So how much time or machinery or the combination you put into fishing along that bottom level of the graph, and on the yield on the y-axis. So if you don't spend very much time fishing on quite a plentiful stock, you'll actually get quite a bit of fish. So I'm going to just use my cursor. So moderately fished, you still get a pretty good amount of fish to take home. Intensively fished, you certainly get more. There's a level at which that fish stock, which is just a group of fish, is what's called fully fished. And the reason it's called fully fished is because if you fish more than that, your yield will start to decrease per unit effort. It will also decrease over time. If you take too many fish past what is sustainable yield, like if you're down here on the overfishing, the next year your yield will be lower, up to a depleted fish stock. and a complete population crash. So we've seen the complete population crash in certain fish populations. The cod stock off the eastern Atlantic and Newfoundland is a depleted stock. Certain stocks of tuna are completely depleted. So we have certainly experimented with the concept of what is a sustainable yield and tried through international agreements, through treaties, through various things to keep fishing levels at or below a level where the stock is fully fished and where fishing can continue. So in this case, the reason I'm talking about this is that a stock in that sense is just a group of fish, any one of which can be part of an income from that year. And so the stock is actually the reproductive and ecological capacity, and the income is how many fish you catch. So that's a stock and a flow sustainable yield. So in that sense, the capital, the actual ingredients of the capital, some of them are the same as the ingredients of the income, the flow. So that's different, completely different from Smith's conception, that Adam Smith's conception that capital was the machinery, and the income or flow was like what was being produced, like the shoes or the dresses or the coal ore. So one of the reasons I'm talking about this is that this is a really basic type of system, a capital, stock, and flow, and it's one of the first ones we'll get into when we start reading Meadows in week 3. You can, in the sense of a sustained yield, you can actually create through investment a level of capital sufficient to produce a flow of stock. So if you can do it through an investment, that's a capital stock. So this process of production, of catching or taking or yielding from your productive stock, it might deteriorate the quality of the capital, the productivity of the capital. So in accounting, we call that depreciation, some degradation in the productive capacity over time. And you can, ideally, you can ensure that you're investing to counteract the depreciation, and that would be a sustainable condition of that capital stock. The depreciation might be slowed or reversed through investment, maintenance. In the sense of an ecological stock, you would invest in making sure that the ecological capacity was not affected by pollution. So a capital stock, here comes the definition, a capital stock in which investment over the year was sufficient to maintain the productive capacity is a sustainable stock. So I'm just going to use another example where sustained yield is also very commonly used in forestry definitions. So they're like the fisheries, you have a stock which includes the things that you're going to take as income. So the stock in the timber industry is actually a forest with soil. So the stock actually includes the soil organisms and the soil health and the reproductive capacity of the trees and the hydrology of the environment, some of which can be affected when you start harvesting. And then the flow in this is how many trees you can take in your annual harvest. So a sustained yield would be something in which the age class distribution of your forest was actually going to be the same over time. I'm just rethinking that because of course a forester would argue that you would want a forester might argue that you would want to be harvesting so that you're taking the most productive trees in terms of fiber, so that you're taking the trees when they're 80 years old. In that perspective, you know, an old growth forest is actually kind of decadent because it's not adding fiber as much at the same rate. So I could have used a better graphic here, but anyway, if you had depending on the values you're counting, your sustained yield in forestry could be just an equivalent amount of fiber every year into the future, or it could be an equivalent amount of fiber and an equivalent amount of soil health, and, you know, ideally it would include those features of the capital stock that are required to make sure that you can continue to produce trees or lumber or fiber into the future. So in that capitals framework, which I was talking about, where the definition of capital has gone into the capitals framework, sustainable development is a condition in which future generations have an equivalent level of capital, equivalent level of productive capacity. They can also take fish, they can take trees for lumber or whatever trees are used for in the future. And that gets us to one of the arguments around that intergenerational equity definition. There's an argument among economists about how much you can substitute one capital stock for another. One of my professors of natural resource economics used the example of the peat bogs, which peat used to be dug as a source of home heating in northern England and Scotland. And he would say that, you know, by the time all the peat bogs were dug, or enough of the peat bogs were dug, that source of home heating was no longer used. That source of home heating was going to be running out, that people would have developed a substitute for burning peat on their stoves, in their stoves. And so he thought it would be foolish to have mount a campaign, you know, save the peat bogs, because in that view, something better, more efficient, cleaner will come along through the workings of the market. Well, some natural capitals can't be replaced. Others might be substitutable. On the other hand, the Daly definition that I started out with, and many other people argue strongly against assuming that there's going to be substitutability. You know, the replacement of various kinds of natural capital with either some other natural capital or man-made capital. And we'll get into that certainly when we talk about energy and climate change. To what extent, for example, can we substitute renewable energy sources for the fossil fuel-based energy sources that our current society is using for its primary energy source. Again, I just want to note, if you're not in the community development program, you might not be familiar with the capitals framework, which is it's kind of a useful thing, 7 types of capital. So I included a supplemental reference in the readings if that's your situation. So that difference between how much substitutability there can be between different stocks of natural capital is strong. One is called strong sustainability, one is called weak sustainability. Strong sustainability is where all stocks of capitals, particularly natural capitals, are going to have equal productive value for successive generations. So we're not going to continue substituting, say, when we use up the cod stock, we're going to substitute for whitefish, we're going to substitute for tilapia, we're going to substitute for eventually grains, soylent green. Weak sustainability is that process of substitution, so that the total value of the capitals, the productive capacity of our economy, is the same for successive generations, no matter what the particular protein source is. So as definitions of sustainability, both strong sustainability and weak sustainability say that future generations will have the same total value of productive capacity. In other words, they're going to need to be able to, not the same dollar value, the same nutritional value, the same ability to produce the goods and services that we need. In weak sustainability, future generations have less choice. We don't currently have the choice to become cod fishermen. We don't currently have the choice to have all the live coral that we once had sustaining the ocean. So we have, in that sense, we have fewer rights. We have fewer degrees of autonomy because of the environmental degradation or the deterioration of capital stocks that have gone before. So which one of these should we be trying for into the future? Now, we have been talking about ideas that were developed from the 1920s through the 1980s into the early part of the 2000s. So of course, at this point of the climate emergency and looking forward, we don't have the ability at this point to ensure that strong sustainability is a condition that we can meet moving forward, because we already know that we've set in motion climate impacts that are going to be affecting the next, well, we have a pretty good idea about what's going to probably happen in the next 150 years, which is, say, 7 generations. And we know that we have already acted in such a way as to degrade what I'm going to call the climate stock. So we can't really meet the strong sustainability condition for weather, for the productive stock of our agriculture, or because there's a lot of uncertainty in it, but we definitely know that we're not leaving future generations with the same amount of choice over that. So and that is one of the reasons why people talk more about resilience than they do now about sustainability. But these are still important core ideas when you think about what are future generations going to have to choose from. I think it's good to go to these definitions and think about them. So I already talked really in the last lecture about the problem of growth when I was talking about the discount rate, that right now in our current system, our investment requires a return on investment, some percentage of growth. So our capital, our investment, and to some extent, possibly our stocks must yield something equivalent to an interest rate. So when we're logging is close to my heart because I'm on a community forest board. So we're a nonprofit, so we don't have to log in such a way to return any kind of value to shareholders, but we are expected to return a value to the community. So our productive capacity of our forest is expected to yield that return in social good at least. But in most situations, certainly for-profit corporations, investors seek a return of some amount of investment or some percentage. And if you're not able to do that as an economic undertaking, your investors will go elsewhere, which will affect your access to capital. So the economy, I apologize, that's a typo, must grow each year. But what room do we have for growth? So that gets us to the carrying capacity concepts. What's the Earth's carrying capacity? And that framework of definition. So that definition, sustainable development is a condition in which human society lives within the ecological carrying capacity of the Earth. So what's carrying capacity? Well, it's really a definition from ecology. So if you think about deer or not rabbits, because their population goes like this, but think about, well, so does deer. Okay, think about deer. A number of individuals who are supported in a given area within the natural resource limits without degrading the natural, social, cultural, and back to a human definition, social, cultural, and economic environment for present and future generations. Can be improved by technology. The carrying capacity of a place might be improved by technology of composting, a technology of how you use a field or a soil. And carrying capacity of a region or a place can get smaller from degradation. So again, it's an ecological concept. This is back to deer. This is a concept, this is a picture, excuse me, from today's Hunter, which gives you a sense of what that's from. So if you think about deer, when you look at this, you have this sort of environment. The forest is the bucket. And then you have certain leaks in the bucket. For example, you might have accidents or pollution or disease or starvation would be leaks in the bucket from the perspective of how many deer you can hunt every year. Predators are a leak in this bucket. Like I said, this is not a diagram of the total ecological carrying capacity. It's just how many deer might you get from an area. So that you have some level of annual production, which is fundamentally sunlight, which makes the grass grow. And then you have some level of hunting of individuals from that population where you'll still have the same productive stock the next year. Again, it's another system type we're going to look at later in the semester. So you have input, that sort of what comes into an environment every year. In this case, you might have sunshine, which is your fundamental energy of photosynthesis and energy for the food chain and the soil microbes. And however we think about this, Meadows will talk about bounding. We use it in a sort of a fixed area. So sunshine and this fixed area or environment equals the carrying capacity or the population that can be supported, and with some level of removal of hunting so that you have a sustainable carrying capacity for an area. Now this is from this image. It's one of my favorite images. It's from Herman Daly, again, back in the 80s. His macro view of the macro economy. So think about the human economy in its pot, which is the world. So we have a world with the sun shining on it and clouds and nutrients and the sort of the general ecological natural processes, as well as all the insects and species and animals that are reliant on those same fundamental energy sources. And when the human habitat was a relatively small part of that world. There was lots of room for all of those other processes, lots of energy for all of those other processes and animals. And whereas as our population gets larger and our economic removals from the ecological system get higher, we have what he calls a full world condition. So at this point, so you see he's defined the entire natural capital as this pale circle and the man-made productive capacity as this box. So his argument really is that particularly in a relatively full world situation, we can no longer count on different kinds of natural capital to be available to substitute when we use something up. So we get to concepts of limits, which is something relatively new in economics. So the capacity of natural capital to produce that kind of natural income to the economy is limited. Daly argues that the stock of natural capital is finite. I think we can agree on that, even if you were a flat earther. If that were a flat Earth, you could still see that it's limited, and even if it is a sphere, I'm teasing, the stock of natural capital is finite. And to me, it's really easiest to conceptualize when you think about the stock of energy coming into the world that fuels all those, the climate system, the soil systems. It's really the energy from the sun. So the more of that I'm missing the word for it, that simple ecological productivity that the human system takes up and uses, the less of it is available for other systems, and the less substitutability there can be. The variables in carrying capacity in that picture are the different technologies, which include organizational and physical capital. It certainly includes culture. You know, how much is it socially acceptable or socially prized for each individual to consume or to use in their, anyway, different technologies and cultures can be employed to yield different levels of production from the same stock of natural capital. And our economy is typically measured in dollars, and there's really great variability in what the natural capital content is of different dollars. We're all in this online world right now, and so we're driving less to different places, so there's less natural capital being used up. If we're driving less and flying less, we're not using up the same stock of natural capital, but we're still doing some of the same things, like going to school. So there is variability in the natural capital content of dollars. So back to that concept of substitutability. What is our ability to substitute different things that contain less natural capital for others? And then finally, I want to get to the no growth argument. If economic productivity were a function of natural resource input, then the economy would have a limit and could not get any bigger. So you could not have that 2% growth in the economy every year. And to the extent that those two ifs are true, we have to say that's also currently true. But I would just say there is some, what I would call, misplaced concreteness in this argument. because many forms of economic value, the things that humans pay each other money for, have almost no inputs of natural capital. So the more we pay for things based on status, and the more the different kinds of status purchases we make, they can be quite large amounts of money that we buy for things that have very little natural capital. You could pay a lot more for much smaller items of clothing, for example. Then you can still have some kind of increase in dollars in the total economy. We're kind of talking on the edges here. We do have some changes to make for sure. So where I see some hope, a little bit of hope in the growth problem. The growth problem being that we're taking up too much space in the world right now. To me, that's the growth problem. We're living off the natural capital stocks of people 7 or 8 or 9 or 10 generations hence, our grandchildren's grandchildren. So what's the hope in this growth problem? Well, there is variability in how much return is demanded by investors and of what kind, especially if investors are committed to a place. We can read about this in Bill McKibben's Deep Economy is one I like. I think about it when I work on nonprofit projects or B Corporation projects. There can be economic activity that provides things that people need and the jobs and income that they want without necessarily requiring that percentage return. So we can investigate those kinds of opportunities. Another aspect of hope is that development has many aspects that are not directly tied to the productive capacity of a natural stock. With the exception of ecosystem services, which are some of our most fundamental, the water that we drink, the air that we breathe, those are ecosystem services. Those, we're fundamentally tied to those natural stocks, and we need to maintain them and invest in them. But there are other aspects of development that are less tied to natural stock. We're not in an industrial economy anymore. And it's important at the same time to think about many forms of economic activity and economic development are directly tied to a healthy environment. For example, it's an economic activity to transform our economy to a green economy, to mitigate environmental harms, to do those kinds of activities. Those are economic activities. They do provide jobs, income, and we can start to make those kinds of investments. They don't provide that that financial return. They provide value return. So, what are the takeaways? Most definitions of sustainability include some concept of a stock and a flow. The stock could be something as large as the Earth's total productive capacity, or the soil health in a state, or the gravel reserves in a county, or even a stock of healthy and educated persons. For each stock, there's going to be some flow of consumption, and for renewable stocks, there's a flow of rebuilding the stock. So we'll get into these more in the Meadows readings. Intergenerational equity can be addressed through equal access to these stocks. You're thinking, this is so abstract, how am I ever going to use this? You will. You'll learn to, we'll be using these concepts. And I must say that equality, or the more human rights oriented definitions, are much less amenable to this kind of measurement, this kind of criteria. So that gives us a review of the, what I call the typologies of definitions of sustainable development, sustainable communities.